Good day, students. So welcome to part 4 of our Algebra 2 Trig Regents review for January 2014. In this installment, we're going to be going over problems 21 through 27. All right, let's take a look at problem 21. It says the expression, the third root of 27 x squared times the third root of 16x to the fourth is equivalent to, so let's rewrite it, the third root of 27x squared times the third root of 16x to the fourth. Now, since these roots are the same, we can combine them into one. Okay, so the third root of the product of the radicants, 27 times 16 times x squared times x to the fourth. Okay, now I'm going to proceed to express these two numbers in exponential form as a power of our primes. So we're going to have the third root of 27 can be written as 3 to the third power, and then 16 can be written as 2 to the fourth power. Okay, so if you're wondering how I did that, you can simply use your factor tree and find the prime factor decomposition of those numbers. So you can have 27, just break it down, 3 goes here 9 times, 3 goes here 3 times, so this is 3 to the third. And then you do the same thing with 16, 2, 8, 2, 4, and then 2, 2. Okay, so as a power of primes, this is 2 to the fourth, and this is 3 to the third. And then these two, using the product property of exponents, we recall that if you have a to the x times a to the y, if the bases are the same, all you simply do is add the exponents, right? So in this case, I can combine these two and express it as x to the 2 plus 4, 6, x to the 6th power. All right. Now let's go ahead and use the nth root property of exponents. I can express this as the radicand 3 to the third times 2 to the fourth times x to the 6th raised to the what? Using the nth root property, I can write this as 1/3. Okay. Now, if I use the power over product of powers property of exponents, it gives me the ability to distribute this power to the powers inside this parenthesis. Okay. So we are going to have 3 to the 3 over 3. Imagine you can just put this over 1, okay? And then just multiply. So 3 to the 3 over 3, 2 to the 4 over 3, and then x to the what? 6 over 3. Okay, we're multiplying this power by the powers, okay? So now we're going to have 3 to the 3 over 3 is just 3 to the first power. And then 2 to the 4 over 3, I like to write this as mixed numbers. It's going to be 2 to the 1 and 1/3. And then x to the 6 over 3 is x to the second power. So what we have now, you notice that this power is this is a whole number, this is a mixed number, this is a whole number. Powers that are mixed numbers are a combination of a radicand and an integer, okay, and a non-radicand. So what can we do here? What I'm going to proceed to do here, I can write this as 3 times 2 to the 1 times, watch this carefully, I'm going to write this as 2 to the 1/3, okay, times x squared. Now, how is this possible? Remember what we talked about up here? When you're multiplying, you add the exponents. Also, if you have a sum of exponents, you can split it up into this form, okay? So that's what we have here. This is 1 and 1/3. This is a sum, so I split it into 2 to the 1 times 2 to the 1/3. I'm separating the integer, separating the whole number, which represents a non-radicand, from the fractional exponent, which represents a radicand, okay? So now what does this become? This becomes 3 times 2, which is 6, and then x squared, and I'm left with this 2 and 1/3, So using the nth root property, I can write this as a third root of 2. Okay? So our answer is going to be option number 4. 6x squared times the third root of 2. Alright, let's move on to the next problem, problem 22. It says, which sketch shows the inverse of y equals a to the x where a is greater than 1? So remember, if you want to find the inverse of a function, you have to reflect the function about the line y equals x. That's if you want to do it graphically, okay? So to find, let's write down some notes. To find the inverse of f of x graphically, you reflect it along y equals x, okay? Along the line y equals x. So just reflect it along this line and then you get the inverse, all right? Okay, so first thing we have to do is we want to identify this line y equals a to the x and then see which one is an accurate reflection along the line y equals x. What does the line y equals x look like? Something like this. So that's the line y equals x. Okay. All right, so let's go ahead and sketch a graph of, see what the graph y equals a to the x looks like, okay? So in this problem, we can make use of our graphing calculators to have an idea as to what the function looks like. Remember, a is greater than 1, so we can pick any value for a that satisfies this requirement. So let's test y equals, how about we pick 3 to the x, okay? So we're going to graph this using our graphing calculators. All right, I have mine here, so let's see. Let's graph 3 raised to the x power and see what it looks like, okay? So press enter and then graph. All right, that's what a typical exponential function looks like. We shouldn't be surprised about that. So let's go ahead and graph it. So if we graph it, it's going to be something like this. Okay, if we reflect this line along the line y equals x, what do we get? Now, one thing you want to notice, if you had just graphed the original function y equals a to the x, right? If you graph y equals a to the x, and you thought you were done, you'd have selected option 1. This is wrong because this is the function. We're asked to find the inverse. Okay, so you have to be really careful to make sure you read the problem completely, or else you can make silly mistakes. Okay, so this is not the answer. We want to graph the inverse. So if we reflect this line along the line y equals x, what is it going to look like? It's going to look like this. Okay, now reflection along the line y equals x. So which of these graphs looks like the reflection right there? Let me use a different color. So make it blue. So that goes the reflection right there. This is y to the negative 1, the inverse, not the reciprocal, okay? This is the inverse of that function. It's basically log base 3 of x. It doesn't ask you for that, but I'm just telling you what it is. Okay, so which of these options looks like the blue function? The reflection of the exponential function along the line y equals x. We can clearly see that the answer is option number 3. Okay, so that's your answer. All right, let's take a look at problem 23. In this problem, I'm going to make a mistake deliberately, and I will see if you can catch my mistake, and then I'll go back and fix it, okay? So watch carefully. We're going to try and find out what this is equivalent to. So we have x squared plus 9x minus 22. We have that divided by x squared minus 121 divided by, now this division, if you're dividing by term is the same thing as multiplying by the reciprocal, right? So I'm going to multiply this by the reciprocal of that. 1 over, now x minus 2 minus x, I can reverse the order and write it as negative x minus 2. Okay? If you switch the order of a difference, you have to introduce a negative sign there, because we know that subtraction does not commute. All right, so that's the setup that we have. Now, what we're going to do is go ahead and factor where applicable, so we can know what to cancel out. So we have to factor the numerator on the left and also the denominator on the left. So let's start with the left numerator. Remember, I told you I'm going to make a mistake somewhere. See if you can catch it. Left numerator is x squared plus 9x minus 22. Let's factor this using the x game. So AC goes on the top. AC is negative 22. B is 19. So what works here? 11 times 2 works. Let's see. Actually, on the bottom we have 9, not 19. It's just 9. All right. So 11 minus 2, make this negative, so the sum is, okay, perfect, that's it. So the factor form of the numerator is x plus 11 times x minus 2. Okay? All right, now, how about the left denominator? Left denominator, we have a difference of squares. Hopefully you remember how to factor a difference of squares. We have x squared minus 121. And then the formula for factoring difference of squares, a squared minus b squared is equal to a plus b times a minus b. Okay? So how do we do that? You just take the square root of the first and the last term, and you find the sum and the difference of the roots. Okay? So we're going to do the same process here. We root the first and the last term, and then find the sum and the difference. So we'll have x minus 11 times x plus 11. So that's the factored form of the denominator on the left. So this expression now becomes the factored form x plus 11 times x minus 2 over x plus 11 times x minus 11 times 1 over negative x minus 2. Okay? All right. We'll notice that some cancellation action is happening here. X plus 11 goes here 1. X plus 11 goes here 1. X minus 2 goes here 1. X minus 2 goes here 1. So final answer is going to be 1 over x minus 11. Okay? Our answer is option 2. Is that the answer? Absolutely not. That's wrong. Okay, because I told you I'm going to make a mistake, so that's not the correct answer. Did you spot my mistake? What is the mistake I made here? Well, the mistake I made is right here. If you notice that there's still a negative downstairs, there I dropped it. Okay, but you don't do that. You can't just drop signs like that. Okay, so we have to keep it there. Now remember what we did initially when we switched 2 minus x and introduced a negative. If I distribute this minus to these two terms, guess what happens? You're going to have plus x minus x plus 11, or 11 minus x. Okay, when you switch the order of a difference, you have to switch the sign of the entire quantity. So that becomes 11 minus x. So our final answer is option number 4. All right, let's take a look at problem 24. This is a rational inequality that we're solving here. So first thing we want to do is find the boundaries. Okay, so let's find the boundaries. Find boundaries. if you look at this problem, you can see, if you look at the options that you have, you can guess what the boundaries are, okay? You can guess that the boundaries are going to be 0 and 5, because those are the only numbers that are provided there. But how are our boundaries 0 and 5? Let's assume that we don't know that those are our boundaries. First thing you want to do is you want to look for where the function is undefined. So what makes the expression undefined? So you're looking for discontinuity, so to speak. All right, so actually one of the boundaries is 2 and 5. I made a mistake, 2 and 5. So what makes the expression undefined? What makes the expression undefined? What makes the expression undefined is what makes the denominator 0. Okay, so what makes the expression undefined? You set the denominator to 0 and solve. Okay, so the denominator here is x minus 2, which is nice because we don't have to factor anything. X minus 2 equals 0, x equals 2. That's our first boundary point. And then the second boundary point is you solve the related rational equation. Solve the related rational equality. Okay, what am I talking about? Well, you just treat this inequality as an equality and solve it. Whatever your answers are, that's going to be your second boundary. Okay, so let's go ahead and do it. We're going to treat this as an equality. X plus 16 over x minus 2 equals 7. So you might wonder, what are we looking for boundaries for? Well, they help us to test to see the feasible regions where the values of x satisfy this inequality, okay? All right, so let's see. Solve this, put this over 1, treat it like an equality, cross multiply. You have x plus 16 equals 7x minus 14. Notice I distributed this 7 to both of them, okay? Now I can get x by itself I can subtract x from both sides and add 14. Okay, just doing 2 steps simultaneously. And then using the reflexive property of equality, I have 7 minus 1 is 6. 6x equals 16 plus 14 is 30. So x equals 5. Okay, so there goes our second boundary point, our first boundary point. Now what are we going to do? We're going to test the intervals between these boundary points to see which one is good, which regions satisfy the inequality. So let's draw our interval. In there we're going to graph our boundaries. First one is at 2. Second one is at 5. So since we have 2 boundary points, that means we have 3 intervals. Interval 1, interval 2, interval 3. For each interval, we're going to test values of x for our inequality. Interval 1, what is a number that's less than 2? How about we pick 1? Interval 2, a number between 2 and 5, we can use 3. Interval 5, a number that's bigger than 5, we can use 6. Okay? All right, now let's do our test. So for our test, we're going to test interval 1, where x equals 1, and see if it satisfies the original inequality, which is x plus 16 over x minus 2 less than or equal to 7. Okay, so that's what we're going to be doing right now. Okay, so plug that in and see if we have a true or false statement at the end of the simplification process. So put 1 in here. We have 1 plus 16 over 1 minus 2. Is it less than or equal to 7? That's the question, is it? 1 plus 16 is 17. 17 over 1 minus 2 is negative 1. Is that less than or equal to 7? 17 over negative 1 is negative 17. Is negative 17 less than or equal to 7? The answer is yes. So interval 1 is good. This is part of our solution region. What do we do now? We test the second value, which is x equals 3. Okay? So this problem is a pain, but we have to do it. So we're going to test x equals 3. The same process. We're going to plug in 3 into the inequality. So interval 2 is what we're testing now. Plug 3 into the inequality and see we have a true or false statement. So we're going to do 3 plus 16 over 3 minus 2. Is it less than or equal to 7? Let's simplify that. 3 plus 16 is 19 over 1. Is 19 over 1 less than or equal to 7? Absolutely not. This is a fail right here. So this interval 2 is no good. Are we done? No, we got to test interval 3. Same procedure. You have to test every interval. You can't make any assumptions or you can make mistakes. Okay, so interval 3, we're testing x equals 6. The question is 6 plus 16 divided by 6 minus 2 divided by 6 minus 2, is it less than or equal to 7? Is it? Let's simplify that. 6 plus 16 is 6 plus 16 is 22. 6 minus 2 is 4. Is 22 less than or equal to 7? That's the question. 22 over 4 is, if we do the math, it's 5 and a half, right? So is 5 and a half less than or equal to 7? Absolutely, 5 and a half is less than 7, right? So this is good. Interval 3 is good. So we see that the only intervals that are good are interval 1 and interval 2. And interval 3, sorry, 2 has to be excluded. 3 is included because you have that line underneath your inequality. So our answer is going to be something like this. With 2 excluded, any value less than 2. And then with 5 included, any value of x greater than 5. That's our solution region, okay? So we can clearly see that our answer is option number 3. All right, let's move along to the next problem. All right, so for problem 5, it says which represents a graph that has a period of 4 pi. So if you think about the equation of a trig function that has a specific period, let's say we have, looking at all this format right here, if I can write it as y equals a sine bx. If you have a trig function in this form, how do you find the period? Do you remember the formula to find the period? The period is 2 pi over b. Okay? So period equals 2 pi over b. So in this problem, we know that the period is equal to 4 pi. So if I can find the value of b, then I can know what the correct answer is. So for this problem, this right here, 1/2 is b, 2 is b, 1/4 is b, and 4 is b. How do we know that those are b's? Because they are the coefficients of x. So which of these b's is the correct one? Well, let's solve for it. Okay, so our period is 4 pi. 4 pi is equal to 2 pi over b. Okay, put this over 1, cross multiply. You have 4 pi b is equal to 2 pi. And divide both sides by 4 pi. 4 pi here, 4 pi there. Cancel, cancel. B is equal to 1 over 2. Okay, because pi goes here 1, pi goes here 1, 2 goes here 1, and 2 goes here 2. So B is equal to 1/2. So we can clearly see that our answer is option number 1. All right, let's take a look at number 26. This is a factoring by grouping example. So we have x squared times x plus 2 minus x plus 2. So factoring by grouping, you notice that these two quantities are identical, so we have to factor it out because they're identical. So we factor that out, so we're going to have x plus 2. Okay, if you factor these two quantities out, what do you have left? Well, to help you see what the answer is without much difficulty, what number is in front here? The number in front of this quantity is a 1, right? So when I factor out these two identical quantities, x plus 2, I am left with x squared and negative 1. You see that? That's the beauty of factoring by grouping. You're left with x squared minus 1. Now, what is this? What is this right here? X squared minus 1. It is a difference of squares, right? And remember how to factor difference of squares. A squared minus b squared is a plus b times a minus b. Okay, so we're going to have, this is going to be x plus 2 times x plus 1, x minus 1. All right, so final answer is option number 4. Okay, let's move on to the last problem in the multiple choice problems for this review series. It says approximately how many degrees does 5 radians have? So we know that pi radians over 180 degrees is equal to 180 degrees over pi radians, right? And is equal to 1. So we're going to be making use of one of these conversion factors to change 5 radians to degrees, right? So we have 5 radians over 1 degrees. So I need to be making use of one of these conversion factors. Am I going to use this one or this one? Which one am I going to use? They're both 1, but one of these variations of 1 can enable me to express this degree measure in degree form. This angular measure, sorry, in degree form. So I'm going to pick the one that cancels out the radians and leaves me with degrees. So since there's a radian up here, I need the one that has a radian downstairs so the radians can cancel out. Okay, so this one fits the bill. I'm going to use this one. So I'm going to have 180 degrees over pi radians as my conversion. So notice what happens. These radians cancel out. And then we have 5 times 180, 900 degrees over pi. Okay? So that's our answer. Now, if you look at the options we have here, this is close, right? This is 900. But that's not the answer. It's a trap. Okay, so let's figure out what the answer is. We just use our calculators to evaluate what this the final answer is. Remember, pi is a number, 3.14, da da da. So we're gonna do see 900 divided by pi, and we're gonna have an approximation 286.4. So if we round it to the nearest whole number, is 286 degrees. So this is approximately 286 degrees. All right. So we can clearly see that our answer is option number 1. So that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel so you can get updates to the remaining of this review series. Please give us a thumbs up if you like this clip. We really appreciate it. More clips can be found on mathgotserved.com/testprep. Look under New York Regents and then you get access to all our review tutorials. Thanks again for watching and have a wonderful day.